I'm Amanda Steinberg, and my lectures on Chapter 3, Section 3, pages 94 through 101. This section of the chapter first talks about the intensity of the controlled stimulus and the unconditional stimulus. The strength of the conditioned response is stronger the more intense that the unconditional stimulus is. The magnitude of the unconditional stimulus determines upper limit learning. The strength of the controlled stimulus is important because the louder or brighter it is, the more attention grabbing it is, and the more likely that the subject will respond to it. However, it shouldn't be too attention grabbing because it may startle the subject being tested. For example, in Pavlov's experiment, if a fire bell was used instead of a bell to trigger the dogs, they might have been scared and elicited a completely different response out of them. So salient and not overpowering controlled stimuluses are always the best. It next talks about pseudo-conditioning and sensitization. Sometimes the conditioned stimulus causes naturally eliciting a response. This can be problematic, especially if the response elicited looks like the response that's supposed to be conditioned. So how do you tell the difference between the two? So for example, if you're shining a light, you can cause the subject to blink its eye without conditioning. So a way to fix this is if the light was the controlled stimulus and an air puff was the unconditional stimulus. If you're doing an eye blinking conditioning experiment, you can start the light, which is the controlled stimulus, at a very low level and increase it each trial. This makes it better known that the subject separates the controlled stimulus from the unconditional stimulus. However, there are two processes besides true conditioning that make the subject respond more and more to the controlled stimulus. That is sensitization, which is defined as an increase in the strength of an elicited behavior that results merely from repeated presentations of the eliciting stimulus. So if this were to occur, we would see an increase in blinking that would not depend on learning to associate the controlled stimulus and the unconditional stimulus. This is just a general state of arousal and excitement. And the second process would be pseudo-conditioning, which is defined as a process whereby a conditional stimulus can evoke responding because the organism has merely been exposed to the unconditional stimulus rather than true associative learning. This differs from sensitization because the counterfeit response to the controlled stimulus is entirely new, whereas sensitization is the augmentation of an already existing response. So for example, the flash of light might never elicit a response to blink on its own, but when exposed to the air puff a few times, the subject might blink because they are both stimuli. Not true conditioning here because there's no association between the controlled stimulus and the unconditional stimulus. So to help this problem, experimenters use control groups. This is a group that can be given the same exposure to the unconditional stimulus alone and then tested for a response from the controlled stimulus. If they responded more to the controlled stimulus, then it's true conditioned learning. Eileen Bernstein thought that pseudo-conditioning and sensitization could be a possibility in taste aversion learning in an experiment with children receiving chemotherapy. She asked the question, could chemotherapy be conditioning taste aversion to the patient's food? So in order to figure this out, she had one experimental group. They ate ice cream, and they were also given a drug that made them nauseated. At the next clinic, the experimental group was offered more ice cream, and they denied it. The control group didn't receive any ice cream, and at the next clinic, they agreed to having ice cream. But to ensure that the control group was given ice cream with no drug, to ensure the experiment, the control group was given ice cream with no drug, and at the next clinic, they still wanted more ice cream, which proves that this is true aversion conditioning. It next talks about conditioned inhibition. Pavlov was responsible for this. He created the term conditioned excitation, which is when a controlled stimulus is associated with an unconditional stimulus, which also leads to a conditioned inhibition. This is when a controlled stimulus is associated with the absence of an unconditional stimulus. A conditioned response with conditioned excitation and inhibition are known as conditioned exciters and inhibitors. An exciter is a positive controlled stimulus. This is a conditional stimulus that is associated with an unconditional stimulus and has the potential to elicit a conditional response. An inhibitor is a controlled stimulus that is negative. It's a conditional stimulus that signals a decrease in the probability or intensity of the unconditional stimulus and evokes inhibition. Pavlov first encountered inhibition when he studied extinction. The next topic brought up was how to produce conditioned inhibition. So again, conditioned inhibition is when a controlled stimulus is associated with the absence of an unconditional stimulus. So the first method used is called differential or discriminative inhibition. This is a procedure in classical conditioning in which a controlled stimulus is paired with the unconditional stimulus on some trials, and on other trials, the controlled stimulus is presented without the unconditional stimulus. So the second controlled stimulus may acquire inhibition. So the second method is called explicitly unpaired procedure. This is in classical conditioning. A controlled stimulus is presented alone and the unconditional stimulus is presented at another time. So they would present the controlled stimulus and then later on they would present the unconditional stimulus, and this would lead to negative correlation, which is where a situation where the probability of one event is lower if another event has occurred in some cases. This also brought up inhibition of delay, which is inhibition that develops to the early portion of a controlled stimulus. The early part of a controlled stimulus signals a period without the unconditional stimulus. And the third method is backward conditioning. This is when the controlled stimulus occurs after the uncontrolled stimulus. This is one of the most fundamental ways to produce inhibition. They also talk about how to detect conditions inhibition. There are two methods to this. The first is the summation test. This is a conditional stimuli that are conditioned separately are then combined in a compound. The procedure can identify a stimulus as a conditional inhibitor if it suppresses responding evoked by the other stimulus and does more so than a comparison stimulus that might reduce responding through generalization. So inhibitor is a negative value and an exciter is a positive value. So both of these together would cancel each other out if both used. So there's something called ordinal predictions. This is a hypothesis that specifies a greater than or less than relationship between two conditions in two groups. The second method is called retardation of acquisition test. This is a condition inhibitor if it is slower than a comparison stimulus to acquire excitation when it is paired with an unconditional stimulus. The results need caution though because other things than inhibition can cause the retarded acquisition. In something called a bidirectional response system, which is an experimental setup where it is possible to measure excitation and inhibition because response levels can go above or below a strong baseline. For example, your heart rate will increase with a fear exciter, and it will decrease with a fear inhibitor. And two methods that do not produce true inhibition are called the conditional stimulus pre-exposure effect, which is also known as latent inhibition. This is an observation that conditioning after exposure to the stimulus later used as the conditioned stimulus in conditioning is retarded, and the second is extinction.